Welcome everybody. Thanks for attending Color in CSS, using new spaces, functions, and techniques to make your site shine. First, I'm going to go over a little bit about who I am. My name is Aubrey Sambor. I am a lead engineer at Lullabot. We are a design, strategy, and Drupal development agency. We're employee owned, which is pretty awesome. I live here in Western Mass. I live in Northampton, which is just about 15 minutes away if you're not familiar with the area. And I've been doing things with CSS for about 25 years, since the late 90s, and it's a lot of fun. You can find me online and on all these places. I am most active on Mastodon. If you're on Mastodon, look me up on labyrinth.social/starshaped. You can read my blog. You can add me on LinkedIn. And if you're in Drupal, if you're in the Drupal community, you can look me up on Drupal.org at Starshaped pretty much everywhere. So what will we talk about today? I'm going to talk about an overview of color spaces that are available today. I'm going to go over what's new in the color modules, level 4 and 5, and a little bit about level 6, but that one's pretty bleeding edge, so I'm not going to go in detail. I'm going to talk more about color functions and how to use them in CSS. I'm going to talk about using custom properties to manage the value of color items, and a better way to do this with something that's new in color module level 5. And then lastly, I'm going to go over two techniques. One that's fairly, well, I don't think either of them are well supported yet, but these are going to be really great for accessibility once they get in and are supported by more browsers. So I'm just going to kind of give you a glimpse of the future with the last things I talk about. So first, I'm going to talk about the current color spaces that are available today. If you are familiar with CSS, these will be things that you are probably familiar with already, but I'm still just going to give a brief overview in case you are not familiar with how to declare color in CSS right now. But before I do that, I'm going to go over quickly what a color gamut is. This is definitely more of like a design subject, so I'm going to be giving a very, very brief overview, not go into detail about what these are, but it's important to know what they are when I'm talking about color spaces. So a gamut, if you're not familiar, it's a range of colors supported on a device, like your computer or your phone or this projector right here. And they're usually displayed as a shape within the human visual gamut. And I've got a picture, like a visualization of what the human visual gamut looks like. And the human visual gamut is a range of colors that the human eye can detect. And there's a couple examples of gamuts here. I have sRGB, which has been the gamut that has been around for, I think, since the mid-90s. And it's what most like CRT monitors and like older school like devices would support. And then P3 is a newer gamut that this Mac, I think all newer phones and computers support. Hopefully this projector supports it. Guess we'll find out when I'm showing P3 stuff. But either way, I'll still be able to show you what I have, even if it's not going to be accurate. And yeah, and P3 is also called wide gamut, so you might have seen that if you're looking up what your computer specs are. It might say wide gamut somewhere. And I don't know if this is obvious, but the P3 color range has a much bigger and greater range than the sRGB color range, which is why it's newer. And here is an example of what the human visual gamut looks like. It's the big parabola-looking thing, like the big triangle. That's a view of all colors. It's obviously a representation of colors that are visible by the human eye. And you might be able to see it. I wish I had outlined this a little bit more, but you can see that there's a little triangle within the human visual gamut. And that's representing the sRGB gamut, which is what the web has used up until CSS Module 4. So the only colors you had access to in CSS or on the web were within that little triangle in there with the sRGB gamut. There's other spaces that are within the human visual gamut, and they have different shapes. They're all mainly visualized as triangles. So the P3 probably goes up a little bit more and down a little bit more to the side, so there's more colors. But there's other ones that would have different shapes as well. But this is just showing the total range that the human visual gamut has with what sRGB actually supports. And then if you want to look at some links, you can see more information about this I'll send the slides out or put the slides on the. I'll put the slides somewhere. Maybe I'll put them on Mastodon. I don't know. But either way, you'll be able to take a look if you want to read more. So that's gamuts. Next is color spaces. And this is the arrangement of the colors within the gamut. So these are usually visualized as different shapes within the space. So I have two examples here. The first one on the top, the cube, is RGB. So you can see that it's represented as one side's blue, one side's red, and one side's green, because RGB is red, green, blue. And then the other one I have down there is HSL, which is hue, saturation, and lightness. And this one is usually represented as a cylinder, with the saturation being the radius from radius math from the inside out. Lightness is going from up and down, so it's darker on the bottom and lighter on the top. And hue is a representation of the circumference, so it's like the color wheel, and it's represented in degrees from 0 to 360, and that will show you, or that will determine what color you're using if you're using the HSL color space. And in summary, a gamut is a collection of colors, and the color space is the arrangement of those particular colors within a specific gamut. That's going to be all I really talk about with gamuts. I'm going to be focusing a lot more on color spaces and the way to write them in CSS, which is probably more what you're wanting because you're wanting to define color on your websites. So now I'll go into all these color spaces. And again, first, I'm going to talk about the RGB color space because that's the one that we have only been able to access, or this is the only one we've been able to access since the beginning of the web, up until CSS Color Module 4, which I'll talk to you about later. So again, this is the color space you're probably most familiar with if you've been doing any work on the web with color. And like I said, it's the only space you could really use up until CSS Color Module 4. And this one consists of things that if you've written CSS and you've defined colors, it consists of hex, the named colors, and then the RGB and HSL functions, which have been around for a while, and then HWB, which is new as of CSS Color Module 4. So first, just a summary of what the hex is, what the hex color space is. This is probably one of the first ways you actually defined color on your site. You can see that it's RRGGBB hexadecimal values from 0 to F. The first two are red, second two are green, third are blue. I put FF1493. It's one of my favorite test colors. It's like a obnoxiously hot pink. You can't really see how hot pink it is on the projector, but it's the one I like to test to make sure that my stuff's working. And this one can also be written shorthand if you're defining black. You can just write 000 instead of writing the 6 zeros. So that's hex. And this one has to do with hex in a way, and named colors. These ones are predefined colors to represent the hex colors. So instead of having to write out the RRGGBB, you can just write blue-violet. And that will correspond to the hex value of whatever blue-violet is. Only you don't have to write the hexadecimal stuff. You can just write blue-violet. A limitation of this, obviously, is not every single color has a named color associated with it. So you can't define everything by using these colors. So you're limited in your colors if you only want to use named colors. And I included a list of named colors on MDN, Mozilla Developer Network, if you want to see what the list of these colors are. Next one, and I showed this earlier, is RGB. And this is more the RGB function that you use to define your color in CSS. Again, it mixes red, green, and blue. It's a different way than using hex, but it does the same kind of thing. Up until Color Module 4, the syntax was one way. It's going to have a different syntax. It has a different syntax now after Color Module 4 came out. But up until then, you would write it by using the RGB function with the 3 red, green, and blue values. 0, I just have zeros in here for an example. But you put a comma in between all of them, and these numbers can go from a range to 0 to 255. And then if you want opacity, you would use RGBA and put the opacity at the end, which could be from 0 to 100% or 0 to 1 with decimals inside. Which, again, kind of like hex, it's not very intuitive. Like, what does it mean if I was going to put in RGB, 50, 20, 200? I don't know what color that's going to be. So that's really hard to visualize when you're actually building your site and choosing colors or anything like that. So there are better ways to define your color within this RGB space. And this is why the next one is slightly better, and it's HSL, which again I brought up earlier. And this one, it's the same color space, the same values that you can access using the RGB function. This time you're using the HSL function instead. And what this one takes is the degree, which is the hue, which is the color around the color wheel. You can see a little hue thing here. So depending on what it is, like 200 could be green, 100 is orange. I don't remember what they are off the top of my head, but that's how you change. That's how you choose the colors. They choose the hue of this. And then saturation and lightness are both percentages from 0 to 100%, whether or not you want it to be kind of monochrome toward really, really saturated and bright. And then lightness goes from being really dark to being really light. And it's written similarly to RGB, where you can either do HSL or HSLA. Again, this changes with color module 4, and I'll go into that once I get to that section of the talk, which I think is going to be right after this. Yes. So everything I talked to you about before this slide, this is what you had for options using defining color in CSS. Hex, named colors, RGB, and HSL. With color module 4, there are some new things that are coming down that might be a little more intuitive. And the first one I'm going to talk about after I go over what's new is the support for color spaces other than RGB. And the one I'm going to really talk about a lot is CIE. There is display P3 as well, but there's actual functions that are defined for the CIE color space, so I'm going to talk about those. There's a couple new color functions, HWB, and then the lab and OK lab, LCH and OK LCH. And those 4 are in the CIE space. Again, I will talk about that in a little bit. And then there's some syntax updates for the color definitions. Like I said earlier, initially with RGB and HSL, you had to put a comma between all the values. But now you can just write RGB, number with no commas in between. And if you want to put opacity in there, you don't have to do an RGBA. You could just do RGB, RGB / with the opacity at the end. And also color module 4, there's a new named color. It's a color called Rebecca Purple. This came to be about 10 years ago. There was a person who was kind of a pioneer of CSS named Eric Meyer. He had a daughter named Rebecca, and she passed away from a brain cancer, in 2014. So in honor of her, the CSS working group named a color after her. So that's why it's called Rebecca Purple. Now, I will talk about a new function that comes with CSS color module 4. And this one is HWB. There should be a picture there. Not sure where it is.
Somebody else had this experience.
Yeah, I don't know why it's... Yeah, then it shows up later. Yeah, okay. That's what happened before when I gave this talk a couple weeks ago. I think it was this slide too, so good to know. So, HWB. It's still accessing the RGB color space, but instead of doing hue, saturation, lightness, or just the red, green, and blue channels, this one does hue, lightness, and whiteness and blackness. It's very similar to HSL. You get a better picture of what the circumference looks like here. You can see it goes from 0 to 360, and that is the same as HSL. It's picking the hue. But instead of saturation and lightness, you're just adjusting the whiteness and the blackness of the color. So this representation is showing that it's orange, but then you would move it around to make it lighter or darker, depending on where that little circle is. And you define it similarly to HSL. We do the first is the hue, which is in degrees, and then whiteness and blackness are both percentages. And again, this is using that new syntax with no commas. And so, yeah, that is one new RGB function that is in CSS Color Module 4, which I think came out like 8 or 9 years ago, but it's taken a while for all the browsers to actually support all the things in this module definition that the CSS working group came up with. So now you can actually use this in all browsers. I'm pretty sure HWB is supported in all modern browsers now, so you can use this today. Another thing that is new in Color Module 4 is this idea of a function that's just called color. So there's a lot of all these separate functions for RGB, HSL, HWB. So a generic color function was created so you can just pass parameters to it. Again, this one still only uses red, green, and blue channels. And this one uses decimals between 0 and 1, or percentages between 0 and 100. And again, these are RGB channels. So we have down here, we're using the display P3 color space. So we're defining it that way, and then we're setting the red, green, and blue channels to be the 0, 0.5, and 0.85. And I can show you what this looks like when you're trying to access things in a different color space. And I have a code pen with that to show you the difference between a display P3 color space and the wider range of colors and the sRGB. So we go over to Safari. Safari has a better way to show this. So, good. It doesn't look bad. I wasn't sure if you were going to be able to see the difference between the two rectangles I have up here. So I have two rectangles. One of these is defined by using the P3 space, and that is down here in this line right here, color function, using color display P3, 0, 5, 1.95. And then this one down here is defined using RGB. You can see this here, sRGB, same thing. So it's like lower, it's less than 1. The top one is more than 1 because it has a wider range because it's a different color space. And now I can show you a visual representation of this in Safari because Safari has the right tools to show you this. So I just opened up the inspector and I'm showing you a picture of the color space here. You can see that it says sRGB down here, and you can see that the color is way up here. And you can see that there's a line that goes here down to here. So this all in here is the sRGB color space, and everything out here is outside of that color space. So you can see, because I displayed this, I defined this using the display P3, it's outside of sRGB, which is something you couldn't do before CSS Color Module 4. So it's cool that you could get all these more vibrant colors that are up here using this color space that you would not be able to access if you're just using RGB. And I can show the difference there by also showing this here. Pop this up, and you can see that this is just the RGB color space. You can see because you can change these values to be within that color space. And you can see the blue is not as vibrant or anything like that. So, yeah. So this was something, again, you couldn't do up until Color Module 4. And it's pretty great that it's an option now. Here, back to presentation. All right, next up is a whole new color space, CIE. This one is a lot more technical. There's a lot more math involved in this color space and how to make it and how it was made. I have some technical experience. I went to school for computer science and did math, but there's a lot of math in here that is over my head. But I will talk mainly about what this color space is. So this color space, I think it was originally made a while ago. Like, this has been around for a while, like I think the 70s. And it was modeled after how colors are perceived by the human eye. So that was the focus and where all the math comes in. It is known as being a perpetually uniform space. And what this means is that HSL's lightness isn't uniform across colors. You can see, if I show this code pen example here, but the internet wants to work. Like, it doesn't look very, like, this blue looks a lot more intense than the yellow. I mean, on my computer it does. It doesn't really here. But there are some issues with some colors looking a lot brighter than others in HSL. So people decided to make, where'd it go? People decided to make a different color space that makes it more uniform across colors. And I have an example of how this looks later on. But it's interesting. And there are 4 different functions in here. And the first one I'm going to talk about is lab. And this one is really confusing. It consists of lightness and 2 color channels, A and B, which it just makes a nice acronym, lab, but they don't really stand for anything. The A is arranged from red to green, and the B is arranged from blue to yellow. And you would write it like this, lab 58, -6630. It just means that the lightness is a percentage, the first one there. And then the second parameter, depending on if it's above or below 0, it's either red or green. And the third parameter, below or above 0, it's either yellow or blue. So this is another one that isn't very intuitive. Like, I don't know where -66 is. I know it's more green, but I don't know what more green means. So, this one's got some use, but it's a little confusing. So this is using the same color space, LCH, similar to lab, but it's lightness, chroma, and hue. Hue is all over the place in all of these, but it's in different places, so that makes it confusing. So lightness is the same as lab, just a range from 0 to 100. And then chroma is kind of like a saturation thing, but it differs depending on the gamut and which lightness and hue you have. And it's usually between 0 and 0.5, but again, the 0.5 could be 0.7 depending on what gamut you're in, because the shapes are different and all of that. Then hue is the same as HSL and HWB, range from 0 to 360 around the color wheel. And this one's easier to visualize because chroma and hue make more sense than just A and B. So we have lab and we have LCH. Next up, there are some issues with lab and LCH. So OKLab and OKLCH were created by this guy who did all this math. There's some math in here. You can see right here. Here's some math that he's doing to do stuff to make the colors kind of match up and have like a smooth gradient and things like that. And there were other issues with lab and LCH that he also fixed in this. One of them was the blue in the lab example always displays more purple, while in OKLab it's actually blue. Like, there's some weird issues with if you're trying to do a gradient from white to blue, there would be some purple involved in there, and there shouldn't be when you're going from just white to blue. I can show that in here. So here's an example of a gradient, and this is a gradient that's defined by just saying blue and white. Here it is. So I'm doing a linear gradient. I want it to go from blue to white, and that's it. I don't want any purple. But why is there purple in the lab gradient example, and there's no purple in the OKLab gradient example? It's because there's some weird issues with the math that this Bjorn guy went and fixed in 2020 when he wrote OKLab and OKLCH. So that changes it so that you're not getting that weird purple. And that's why using the OK ones are better than using the lab and LCH, because there's corrections that make the colors more accurate. But I also will show you an example of where, I'll let you take a picture. Okay, you're good?
Yeah.
Okay, good.
Thanks.
I'll show you another example of where OKLCH might be an issue. Speaking of OKLCH, again, this is similar to the way it's similar to LCH, the same way that OKLab is similar to lab, with the similar color corrections to fix the blue hue shifts. The difference with this one is that there's a color picker for this, and it is a pretty complicated color picker. You can see there is lightness, so LCH, lightness, chroma, hue, and this is the opacity. And when you drag these around, you'll see that the shapes change. You can see the hue is changing when I'm dragging this, and it's going out of the range here, so I can only go to there. Then I can drag this one around, and it changes the lightness. So there's a lot of variables that are dependent on each other with LCH, OKLCH. And so that's what makes it a little more confusing. But this is a good way to actually build up colors in OKLCH. There actually is this color picker. So I do find that very useful for making colors in OKLCH. And I've got a code pen. I'm trying to remember which code pen this is. And this is the one where I wanted to show the perpetual uniformity of the colors. Like up here, I've got HSL. I have a pink and a blue defined using HSL. They don't look very uniform to me. They look very, like the blue looks more intense. And down here, they're defined using LCH, OKLCH. And they're using the same, lightness. They're both 70%. And you can tell they're pretty similar. And the HSL up here is also using the same saturation and lightness, 100% and 50%. But they look a lot different from each other than the OKLCH ones. So that's what I mean when I talk about perpetual uniformity. They're not, like the pink isn't pinker, the blue isn't bluer. They're kind of just there and very similar to each other, which is more pleasing to the human eye, which is what the goal is of the CIE color space functions, the labs and LCHs. Yep.
Does it match them on saturation mainly?
The question was, does it match on saturation? In the HSL, the saturation does match. LCH doesn't have any saturation. It goes by chroma. And the chroma is very similar, but it's going to be different depending on the color, as you saw in that example I had in the color picker. You can see that the chroma changes depending on what I have for the lightness. So it won't have similarities there, but when you have the same lightness, that's what makes the colors more uniform. All right, next up. Now I'm going to talk a little more about Color Module Level 5. And there's a couple new functions that come with Color Module 5. And I'm sorry if the LCH and OKLCH stuff was a little confusing. It's confusing to me still, and I'm still trying to understand everything that is going on in there. But still pretty cool to see that you can define different colors. So in Color Module 5, there's a couple new ideas and syntaxes that kind of make your life a little bit easier as a front-end developer writing CSS. And the first one is color mix, which you mix colors within a given color space. There's relative color syntax, which is an easier way to manipulate colors. And then light dark, which I'll talk about at the very end, which is still not supported everywhere, but it will be really good for accessibility once that's supported everywhere. So first is the color mix. I gave a talk last year on if you still need CSS, do you still need SAS in 2023? And I talked about color mix in here because the only way to be able to mix colors before this was using SAS or custom properties in HSL. And I'll talk a little bit about that later. But this right here, you can actually mix colors. You can mix blue and white together and get a lighter blue. And you can choose the color space you want to use. Like the first one I'm saying, just use it in sRGB. And the second one, I have an example of using it in OKLCH. But there's weird color issues using color mix in OKLCH, which is why I haven't really been using OKLCH in my production sites yet. It's cool, but I feel like there's still some tweaks. But I can show you this funky GitHub issue that has what the issue is. And I can make this bigger. Skip all this. But the big thing is, OKLCH. I'm doing the example is wanting to do a color mix, mixing white and blue, using in the OKLCH color space. You'd expect to be a light blue when you're mixing them. Nope. In Chrome, it's pink. In Safari, it's green. And in Firefox, it's this blue. But it's supposed to be this blue down here, which is slightly different. It's a slightly darker blue down there. So there are some issues with using color mix, specifically with the blue and white. It probably has to do with some of those tweaks to the blue and white and OKLCH, and maybe more math needs to be done to fix them. There is, again, so much stuff in this issue. I'm like, all right, there are some smart people who are working on all this stuff in the CSS working group, and it's pretty interesting to kind of try to follow, but I would not know how to fix this problem. But I do have another color mix example in here. Let's click on it. This internet seems to be working. So this is a color mix example. I'll go half an hour. I have 15 minutes. All right. So this is an example of using color mix. The first example is using HSL, and I'm defining the custom properties for the hue, saturation, and lightness in the root and then I am mixing them. I'm making the default color here, which is this default color in HSL, and then to lighten it, and this is what you had to do before color mix. And then to make it lighter, you would have to manipulate the lightness plus 25% here to make it lighter. So that's what you had to do, like create these 3 variables, manipulate one of them to get the result you want. With color mix, you just need to do, like I have the second one here, defining the RGB of this color here. And then for color mix, I just say color mix within the sRGB, pass this variable, and then just say white 50%. So that will mix this color here to be 50% whiter, so it like lightens it up here. So you're not having to like separate out all the custom properties to manipulate one of the values. So with this, you can just mix it right here. And then before we talk about the relative color syntax, and I just gave an example of this, I don't know if I'll go through this one too. We're updating the colors using the custom properties. But yeah, like I just said, you have to create a custom property for each part, like an HSL. You have to create the variable for the hue, the saturation, and the lightness. And if you want to manipulate any of them, you have to do one and then redefine the variable. But there is a better way to do this now with relative color syntax. So this one is a more concise way. It's supported in Chrome and Safari, but not Firefox, which I'm a Firefox user, so I'm bummed out about this. Hopefully it gets supported soon. I should have actually checked to see if it's supported now, but I'll just assume that it's not yet. So to define a relative color syntax, you do HSL from, I'm just saying from green, because I want to define the green, and I just separate out the H, S, and L. So now, those are 3 separate variables in there. If I want to change the hue, for example, I would go down there and do H plus 200. Like, again, because hue is the color wheel, so it's adding 200 degrees to it, so it's going around the wheel to a different color. And so you don't have to separate out the variables here. You could just say the H. I want to manipulate the H part of the HSL. And I've got a code pen for this that I don't think I'm going to be able to show you in Firefox because, like I said, not supported. So I've got it here in Safari. And it's the same example I gave in the slides. It's doing the green here. It's defining the green. And then green's hue is 120 degrees. That's where it is on the color wheel. So I'm adding the 200 degrees down here to make it 320. And making it 320 changes it to this color. So if you need to do anything with manipulating the lightness or the saturation, you'd be able to do the same kind of thing, like using calc to add like percentages or something to it. So that is a good way to manipulate things, especially if you're doing a design system and need to make things lighter or darker in the design system. This is a good way to do it. All right, last up is the 2 color functions to help with accessibility. These ones are also not supported everywhere, but they're also pretty cool to look at, so hopefully they are supported sometime soon. And the first one is light dark. This is a simpler way to add styles depending on whether you're in dark mode or not. There is a way to do this right now with defining, so I'll just pop up the code pen. So you can use a media query. You can use the prefers color scheme media query right now. And you can see I've got the definitions here where the background color is this gray. The text color is this really like dark gray. And I'm using prefers color scheme dark. And when I do that, it'll reverse them. It'll make the background color the really dark color and the text color to be the light gray. So that's a way you can do that now. But with light dark, what you do is you define this color scheme. And there are multiple color schemes, but I'm just going to focus on the light dark one for now, because that's the one that's important here. So I've got that. And then I go and define the light dark background color and the light dark text color. And you define that by doing light dash dark. And then the first color here is the text color. Or the first one is the background color. The first one is light mode and the second one is dark mode. That's what I meant to say there. And so this does the same thing as the prefers color scheme. There's a little less code that you need to do. You don't have to redefine the root twice. And I can show you this really quick. if I can get to my desktop here, and get to my settings. So I do this, and I go to dark mode. You'll see that both of these change because they're both using that prefers color scheme. One's using prefers color scheme, one's using light dark. So when you have it set to dark mode, it changes the colors to be the right mode you're in. I'll switch back to light. And then the second one I'm going to talk about, I want this to be bigger, this is experimental, but it's called color contrast. And this is part of color module level 6, which is kind of bleeding edge. It's not really out yet. And there's still tweaks they're making to this. And it's only supported behind a flag in Safari. So you cannot use this in production at all. And with this one, you're able to define the colors based on what the contrast is. There isn't really a set definition of what the most contrast is yet. Right now it's using the WCAG 2.1 algorithm, but there might be other algorithms that determine the best contrast for accessibility. And I could show an example of what I mean with color contrast. I didn't write this one, someone else did, and I just decided to use their code because it's easier to show that. So you can see it's a screen that says hello world with this lighter background, like a kind of a light tan. And what color contrast will do is if I change this lightness, the text color and the link color of hello world will change if I'm in Safari, which I'm not in Safari right now. So you can see that it doesn't do anything in Firefox because it's not supported. If I go to Safari and I drag this around, you will see that the text, you see the link just changed to a lighter green because it's the color contrast of the background got to a certain threshold, so it changed the link. And if I drag it more, the text color also changes to a white. And so this is what color contrast will do once it's supported. It will go and change this automatically for you so that you don't have to think about that and you can keep like accurate color contrast. All right, so I'm gonna wrap up. There are so many new things happening with color in CSS, and I went through just a few of them. There's the new color spaces. There's new functions like color and color mix. There's easier ways to manipulate color variations using relative color syntax as long as once Firefox can support it. And then there are up-and-coming functions to help with accessibility, such as light dark and color contrast. I've got a bunch of links here to read. I used these links a lot when I was writing this talk, because there's lots of people writing about color right now on the internet, and that's been really great. And yeah, I've had to read the W3 specifications for the CSS color module 4 and 5. That was fun, but it was still interesting. It was a good experience. And then again, more about me. That's the same slide as the beginning, and that's it. I think I have like 5 minutes of questions, but that's my talk.
That's
Yeah.
great. In the very beginning, you showed a triangle, the gamut,
Yep.
and the current RGB. Is it to say that that deep green that was showed at the top left of the gamut, we can't show that? Like if you do RGB and just all green, it's not going to look like that?
Yeah, the question was, I showed a picture of the human visual gamut, and there is an sRGB triangle in there, and the question was, can you access the green that's outside the triangle in sRGB? You can't, no, you wouldn't be able to access it at all, because it's just not part of that little triangle thingy that's there. So that's what like P3 or the CIE color spaces actually, I think, do the entire range of the human visual gamut. So if you're using like OKLab or OKLCH, you'd be able to go up to that green.
But I mean, so obviously you did show it on the screen, but does that imply that maybe the projector
Yeah.
is not? Because I mean, it seems like the edge of that triangle is like, that's not very green, you know?
Yeah,
And I'm pretty sure I've seen greener things on the internet.
yeah. The question was, but the picture had the brighter green, so maybe it does show it. And I don't know, maybe it's like a representation of what it could look like. I'm not really sure. But yeah, there are like examples, like if you're using P3, yeah, you can see a brighter green and things like that.
Cool.
So yeah, it's interesting. It's tricky trying to show color stuff on a projector where it's like, how accurate is this? Is this just a theory, Yeah, so, but yeah, thanks for the question. Yeah.
For the OK HCL, like, have you used that in production? Is that like something that people are using now, and are there polyfills for it? If so,
Yeah, the question was, can you use OKLCH in production now? I'm personally not, but you can. I'm pretty sure all browsers support it now. I'm not sure if there's a polyfill besides using like an @supports. You can say @supports OKLCH and put your OKLCH code in there. But I don't know besides that, like if there's any fallbacks or anything. I looked, like I had this question a couple weeks ago when I gave this talk, and I'm like, there's no fallbacks, so you have to do like supports or something to do that to make sure that it's picked up. But if your users are using modern browsers, it shouldn't be a problem. But if they're using like an older version of Firefox, or if they're still on IE, you won't be using a lot of the color stuff anyway if you're using IE. Yeah. All right. Yeah.
Well, and so so there was some bugs with the OK,
Yep.
you know. So like, do you have recommendations on like what? Like, is that only an issue if you're just using that one feature? So otherwise, it would be fine.
Yeah. The question was, what do you recommend using? Should you use OKLCH? I don't yet. I've read a lot of differing opinions on people using it and people not using it. I don't really like to use it. I've actually still been sticking to RGB color spaces for now, but I think I would hope within the next year or two maybe they'll like straighten out some of those bugs with the blues, especially because there's probably some other bugs that are out there, but the blues are the big one. So yeah, I wouldn't use them quite yet, but it also depends on your user base and all the classic "it depends" kind of answer. So I wish I had a better answer, but yeah. All right, looks like I am at time. I'll be at the after party in case anyone has any other questions. So thank you very much.
Thank you.